I'm going to go over type 3 loose dot structures. These are the ones that have substances that have more than 8 around the middle. And basically what happens is that you put all your electrons down, everything has 8, then you're like, oh, I have extras. What do I do with the extras? So that's the way these are going to play out. So XeF4, Xe is group 8, kind of unique to have a noble gas involved, but they do have loose structures sometimes. 8 for that. 7, because fluorine's group 7, sometimes 4 gives you 28, so you have 36 electrons. Alright, so what do you do first? Stick whatever you have less of in the middle, as always, right? There's your middle. You have 4 fluorines. So I'm going to draw it basically the way it's going to look really in 2-dimension. You could just do your 4 corners and that's fine, there's nothing wrong with that. But I'm just going to do it this way, because I want to. So there's 2, 4, 6, 8 electrons. Alright, so you have 8 electrons and you have a total of 28 left. So we have to put those 28 down. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So when you put those down, you're like, wait a second, I have extras, right? Because 24, 26, 28, 30, 32, you have 4 electrons left. What do you do with 2 extra electrons? You stick it off the middle. Why? Because that's what you always do. If you have extras, just stick it off the middle. Do not do double bonds, do not stick it on the outside elements, don't do anything silly. Stick it off the middle and you'll be fine. This is a really unique structure, it's called square planar. And the way you can tell it's square planar is because it has 4 bonded to lone pairs. Now you could also call it octahedral, I'm not going to do it for that, it's fine. Either one's fine, but this is the correct structure. So the thing unique about this, technically it's non-polar. The lone pairs exist on a separate plane than the fluorines. They're in 2 different dimensions, if you will. So as a result, the lone pairs have no impact on the symmetry of this molecule, because ordinarily lone pairs screw up the symmetry, and that's the reason you have polar. These don't do that, which is very unique. So technically this is non-polar. And since it's non-polar, it's going to be LDF. That's the only structure available for that. Alright, I have 5. You're going to do 7 plus another 7 times 5, which is 35, which is 42 electrons. I in the middle, fluorine, 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 and then one more fluorine. Now, it doesn't matter which extra corner you pick. No, of course not. As long as you have 5 fluorines around the middle, you're good. The weird things I see is students will put F and then put another F off it. No, 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 no. Single middle, unless there's carbons involved, you have 1 middle. If carbons involved, then you can have multiple middles and it gets really interesting. There's some other common exceptions, not common, rare exceptions, but for our purposes, just roll with the idea that you could have 1 middle unless carbons involved, then you could have multiple middles. Alright, anyway, so 2, 4, 6, 8, 10 electrons means I have 32 left. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. I have 2 left. What I do is 2 extra electrons. Stick it off the middle. Doesn't matter which place. No, as long as it's by itself. Like you don't put the 2 dots where the line is, which is implying a double bond, you're fine. You have to pick an empty location when you're putting a lone pair, so keep that in mind. You can put it as 2 dots because the lines are kind of weird. Too many lines here will probably confuse someone if they look at it. So on these I should probably put dots as well, and that's what I'll do for the rest of this. I'll just put dots instead of lines for the lone pairs off the middle. Alright, so you have 6 domains. This is going to be octahedral. Technically it's another structure called square pyramidal. It's a subcategory, we're not going to go into that. You can call octahedral, it's fine, 6 domains. We'll be good with that. Alright, so as far as the polarity, you have a lone pair off the middle. That makes it automatically polar, which means you have LDF and you have dipole-dipole. Alright, SF6, you have 6 plus 6 times 7, which is 42, which is 48 electrons. S goes in the middle, 1F, 2Fs, 3, 4 usual locations. I'm going to put 2 more, 2 other random locations. So 2, 4, 6, 8, 10, 12 electrons. So already you have more than 8 around the middle. So this is a structure where it wouldn't be on 8. All these do. Well, except this one, which goes 2, 4, 6. Oh, this was 2. I'm sorry. So the reason all these go beyond 8 is because of the fact that these have the opportunity because they're from period 3 and beyond. Any element from period 3 and beyond can have more than 8. Anything before period 3, you cannot do this. Like carbon, you can't do this. You can't put more than 8 around it. But anything from period 3 and beyond, you can't. Do you have to put more than 8? No. Just depends on the situation, but it's possible. So anyway, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. There's all your electrons. There's no lone pair or extra to stick off the middle. You're done. And remember, the max you could have around the middle is 6. And that's what these are. There's 6 pairs, which is 12 electrons. So you can't go over that, in case you didn't know. So this is octahedral. And same element all around. So it's symmetrical, which makes this non-polar, which means just LDF, and you're done. All right, SEF4. SE is group 6 plus 28. 4 times 7 gives you 34. So SE in the middle. F. I'm just going to do it this way. You could do it the way we've been doing it up to this point. It's fine. Let's mix it up one sometimes. So you have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. You have 2 electrons left. What do you do with 2 extra electrons? Stick it off the middle. Why? Because that's we always have 2 extra electrons. So you can see this has actually 10 around it, beyond the normal 8 octet, and that's fine. SE is from period 3 and beyond. You can get away with this. So what is the shape going to be? 1, 2, 3, 4, 5. That's going to be trigonal by our pyramidal family. You have a lone pair, so automatically polar. There's nothing to analyze. Shapes, or excuse me, the IMFs, LDF for sure, dipole for sure. No H bond because we don't have any H's. That's easy. SF4, S6 plus 28, 34 again. That was 34 too. But guess what? It's going to look exactly the same. So we'll do this the old way. F. That's okay. Come on. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. You have 2 left over. What do? Stick off the middle. So if you have extras, please don't do double and triple bonds. It's only when you have a shortage of electrons. So 5 domains again, trigonal, bipyramidal. Oops. Sorry about that. Bipyramidal. I spelled that wrong, butchered that. So 5 domains, trigonal bipyramidal. Polarity, this is going to be polar. And you have LDF as your first one. And because you have a lone pair off the middle and the polar, you also have dipole, right? Alright, so that's what happens when you have more than 8 around the middle, or when you have an extra electrons that you need to put somewhere, you all stick it off the middle.